Today's presentation is called Sustainable Learning Environments, Designing for Efficiency and Wellness, which will discuss balancing environmental responsibility with building performance, occupant wellness, and long-term resilience. Our speakers are Lori Cowles, AIA, ALEP, Lead AP, Principal at HMFH Architects, and Stephanie MacNeil, AIA, Lead AP, BD+C, Associate and Sustainability Leader at HMFH Architects. And without further ado, I'd like to turn the time over to them. Lori, take it away.
Thank you, Matt. Thank you, Matt. We are going to focus today on Arlington High School. Arlington, Mass. is a nearby suburb of Boston. And we felt that best to sort of give the lay of the land of the project overall. It is a very large, brand new high school. It serves 1,755 students, just under 410,000 square feet. One of the many unique aspects of this is that it was constructed literally on the same site as the old school building, which meant that it took 4 phases of construction, all while occupied, very complex. It is a LEED Platinum building, and its renewable energy arrays you can see both on the rooftop as well as just beyond over the parking lot. And it has a predicted energy use intensity, a low predicted energy use intensity of 24.7. We are highlighting an overarching programmatic layout of the building with the humanities wing, the STEAM wing, science, technology, engineering, arts, and math, as well as the performing arts and athletics wings. Next. Also, just again, to give a big overview organization, we really optimized the building layout from the very beginning, starting with solar orientation. All of the educational classrooms are either north or south facing in the classroom wings, which is very important for control of light. The building is organized around a central spine. The central spine serves multiple functions, not the least of which it really has become and is a hub of the school where the students are able to really be themselves and be comfortable and create their own autonomy. You see in the section here that it also serves as a way to transition through the grades on the side. From the front to the back is a 25-foot drop. This also gave us the opportunity to create a forum stair and seating area, which again is a real hub for the students throughout the day, really giving a sense of well-being. Next. We're identifying just 2 overarching goals for this project. As you can imagine, a civic project of this size and importance for a community has many, many goals. But from day one, these are the 2 main drivers. One, the community had already set a commitment to be fossil fuel free in the future. Therefore, this is an all-electric building. And then just a brief background without showing all the crazy pictures, really developing a school building that is really centered on the students. And this became a driver from the start as we walked around the former school building, which was built in the 1910s with additions in the 1930s, the 1960s, and multiple additions in the 1980s. And I think even as I described that, you can imagine what kind of a complex this was with corridors everywhere, really no heart of the school whatsoever. So again, these are the 2 main drivers for our design. Next.
And so for today's presentation, we wanted to organize our achievements in these 5 different categories. So beginning with carbon reduction, which is something that's getting talked about a lot right now, especially with the rollout of the new LEED version 5. We'll be discussing both embodied carbon and operational carbon. That operational carbon lends itself into the next category, which is the energy use of the building. As Laura was mentioning, our charge was to really lower that EUI as much as possible. Indoor environmental quality obviously has a large impact on that student experience in the building, making sure that they're as healthy and comfortable throughout all of their day-to-day activities in the building, both the students and the staff. Then we'll be looking at water, and for this presentation, we'll be looking more at the outdoor water retention on the site. And finally, we'll be looking at connections, which is kind of the overarching theme that has reached all of our design goals for Arlington High School, both between connections of the students within the space, connections of the building out to the community. And so we'll go through that in a little bit more detail later on. So to start with, we have one of our favorite graphics that kind of speaks to that description of what is embodied versus operational carbon. You know, there's a lot of talk about the energy that a building is using to run and how much energy you're using for all of your systems. But in the design industry, we're taking a much deeper look now at all the energy that is spent in order to get the materials that we're using to build the building, energy that was used to create those materials, get those materials onto site, erect those materials on site, and construct the building. And so as we're making our design decisions, we have to keep in mind what is that overall impact on the embodied carbon footprint of our building. And so at Arlington High School, we had a few approaches to addressing that. One was through just right sizing and conserving our material usage. When our design started out, we had a much larger kind of approximately 15-foot floor to floor height on the building. We'd done that to make sure that we had enough space for all of our mechanical systems coming through. As the design developed, we took a hard look at that and said, hey, you know, we actually don't, you know, we're finding ways to map out these duct runs. We can lower the height of the building. Let's do that. That's resulting in less material usage, less energy spent to create those materials, get them to site. Additionally, we looked into the characteristics of the materials that we're specifying and using. Those measurements are done and called the GWP, the global warming potential of a material. We looked at the the concrete that we were using on the project. We were one of the first public bid projects to be able to work with our contractors and procure a low carbon concrete, meaning that the additives within the concrete mix were a lower embodied carbon factor. Also in our curtain wall systems, where we might have more typically used an aluminum panel on opaque panels, we swapped that out for a sintered stone product, again, because it had a lower GWP than the aluminum panels would have had. And so then to click over to operational carbon, as Lori mentioned, this is an all-electric building. That was very important to the town of Arlington to stay in line with the town's standards that they had gotten to go towards fossil fuel free. We did have to have interesting conversations, you know, with their science department, who had been relying on gas Bunsen burners. So we still had to work with them and said, all right, well, we'll find a way to get you smaller propane Bunsen burners, but it's really crucial to this project that we're not having any permanent gas hookups for the building. And everyone, you know, through many discussions, everyone became on board with that initiative. And so then to balance out the energy usage of the building, we also do have solar array that you're seeing here. We worked with our engineers to really make sure that we were maximizing the open roof area for those solar arrays. So that meant that we were very strategic about what zones all of the rooftop equipment were going in, and not just the rooftop equipment, you know, where are those plumbing venting stacks coming up through that would also have caused interruptions in the array. We made sure that we were very strategic about grouping those things together to allow for as much possible space for the rooftop solar array as possible. And then to talk a little bit more about the mechanical systems in the building, the town had hoped to pursue a geothermal system for the building, but unfortunately the soil conditions around the site did not allow that. So we went with an air source heat pump system. And we paired that with energy recovery wheels, and in a desire to just make this as efficient as possible. So how is that working? This diagram kind of helps walk through. You have both your heat pump unit that is bringing your heating or cooling to a terminal unit close by to the room, and your energy recovery wheel is helping to preheat or pre-cool the fresh air that's coming into the space, and then that is kind of all mixing together with the room air. And that important thing about that mixing is that there's CO2 monitors within the space, so it's ensuring that the amount of fresh air that you need for the space is coming in, but it's also ensuring that you're not just in the middle of the winter pumping in too much outdoor cold air that then your system is having to overly run and overly heat up. So there's quite the balancing act that goes on with getting the right amount of heating or cooling capacity, the right amount of fresh air, the right amount of air from the space to make sure that it's all coming together to make all the occupants comfortable.
So what we're looking at here is an end of a hallway where we always take the opportunity to have glass and glazing and view and daylight wherever we can. But in this case, it was looking over at a roof at mechanical units. So the first knee-jerk reaction of an architect is to say, oh my God, I just want to block it so we don't have to look at mechanical units. But no, we said we should use this as a teaching opportunity. So we developed the graphic that you did just see and blow up on the slide before and put this on the screen, on the glass, literally highlighting what they were seeing beyond and in relationship to the roof plane, in relationship to the ceiling plane that they could see in their rooms, and really use it as an educational teaching opportunity for the students. And we know that the engineering classes in specific will go here and talk with the students about it. It's a great opportunity for everybody.
On one last piece on the mechanical systems, as I was mentioning, there was that push for geothermal first, and then we had to head towards doing the air source heat pumps. But we had that target EUI that we needed to hit, and this is a 400,000 square foot facility, so that was no easy charge. So the way we got there was by making sure everyone was coming to the table to understand how the building was going to be used. Typically, when our engineers are looking at a building and they're zoning things out, there's a separation of the north glazing and the south glazing because those are going to have different heating or cooling capacities. We took the step to talk with all the users and say, okay, what spaces are your adult ed programs going to be? What spaces or departments have programs that they're hosting clubs after school from that 3 to 5 p.m. segment? What spaces of the building are you running your middle school summer camps out of? And the reason we did that was to make sure that in those more off hours when it's not 100% occupied building, you're not ending up with one classroom up and running in one wing and one classroom up and running in the other wing and effectively turning the whole building on. We want to make sure that those are grouped together so that you're efficiently using your mechanical systems. That's the reasoning why you see at the kind of top of your page what's highlighted in purple. Oh, why is that little chunk of purple within a sea of yellow? And the reason for that is that wing of purple classrooms was identified as classrooms that were going to be used for adult ed in the evening. And that purple box within the sea of yellow happens to be their school committee zone, but that's the district administrative spaces around that. So no one's in those offices in the evening time, but very frequently there'll be meetings in the school committee room. So thereby in that scenario, we're only turning that one unit on because there's adult ed classes and the school committee meeting happening and not running multiple units when they don't need to be. So that was kind of, an example of digging deep, finding out what the client's needs are when they're understanding when they're really using their building to make it run as efficiently as possible.
So Stephanie was talking about the big picture planning for this building and its use, but we all know that the occupants care about what happens in their space and their level of control. And we also know that every person is different. So having controllable temperature within a reasonable swing, but just enough that, again, the teachers and the occupants are able to adjust the space to make it as comfortable as possible for themselves, really creates as much of a comfortable environment for the occupants as possible.
And daylighting and world of control. So, yes, we're all using LED lighting throughout. It's a much lower power usage than older days of, fluorescence. However, again, when you're talking about a facility this big, every little kilowatt matters. So having those daylight centers in the classrooms both optimizes the energy efficiency of the lighting, and it also just optimizes the user experience in the space. So you're not, if you're sitting by a window, you want to appreciate and have that natural light coming in on you and not have a artificial light glaring down at you.
So I want to talk a little bit more about daylighting as it affects the occupants and the users. Starting with what I mentioned earlier is that this building has been designed in such a way that there is a lot of natural light coming into it, specifically into the classroom. So this 90% stat is referred to regularly occupied spaces. So this could be smaller offices and small group rooms. But in fact, the building has 100% of its teaching classroom spaces have natural light and views. In addition to that, the graphic that we're showing here is, we think it's equally important to have a connection to the outdoors, even when you're going from one class to the next. So each of our classroom wings have these multi-story light wells starting at the roof line, coming all the way through and bringing that daylight and connection to the students as they are walking throughout the day. The image on the right is the library or media space. And that too, it's a very, very big space. It does have direct natural light and glazing. It has skylights in the background. I think you can see the light shooting through. But having this diverse array of natural light and where students and teachers can hang out really enlivens the space and increases the sense of well-being and sense of autonomy in the space. We also, no, go ahead.
I'll go first. So now kind of shifting back to the classroom spaces, to look at a classroom from the kind of lens of what is the building doing to make that classroom run efficiently. So looking at the exterior wall, we make sure that, we have very high R value walls, meaning that they're very well insulated. Shifting into the glazing or the windows, we want to make sure that that the glazing is has a high visible light transmission, meaning you're getting in the light that you want, but it's also low heat gain. So it's making sure that it's not emitting that extra heat from the sunlight. And that they also contain high R value, again, for that insulating factor, where we are in the Northeast, that becomes very important. Also, you're seeing very tall, that window is going approximately up to that ceiling edge. We want to make sure that the windows are as high as possible and getting that daylight as deep into the classroom and the teaching area as possible. What you can't quite perceive from this photo is that the ceiling there is actually sloping up from a low point at the corridor up to a higher point at those exterior windows, again, so that we've got ceilings. We kept it low at the corridor side so that we have ceiling cavity to run all of our mechanical, electrical, plumbing that we need to, but then let it get up so that we can get in, an extra 6 to 10 inches or so of window to bring in that daylight. And again, to shift back to the artificial lighting in the space, we're using those LED lights that have a very high CRI rating to them. That's just meaning the kind of the light spectrum and balance that it's supplying to the room is much more full spectrum and pleasing color temperature for the occupants.
So continuing with healthy environment, specifically the teaching spaces, where, again, students spend most of their time, creating the best acoustic environment is so important, whether it's through the high rating of the ceiling to balance out the sound, and various spools, even the furniture having glides on them so it's not scraping and making noise. And one of the most valuable things that we are now doing in all of our teaching spaces is integrating a voice lift system, which is literally the teachers have a very small microphone tied to a set of speakers in the ceiling. So number one, they're not straining their voice. They're not having to yell. They can be heard, even for the kids in the farther away from them. Other elements of healthy environments is we really have leaned into natural flooring, typically made out of linoleum, no stripping, no waxing, again, much healthier environment overall. And having low VOC in our paints, again, gaining the right reflectance to create a really welcoming, comfortable atmosphere within the teaching space. Next. And this is sort of equally important to us when you're in the larger gathering spaces of the building. And we're trying to make sure that the acoustics are comfortable. And so we do a variety of things with acoustic treatments, both with the ceiling tiles as mentioned, but also with acoustic baffles. We also have baffles that have additional acoustic above that to, again, manage the sound in these various different spaces. In particular, early design, before we even start with the finishes, we really think about the volumes of the spaces and creating those different types of spaces for the different occupants. And so not every kid wants to be in the center of this double height space in the middle of everything. Some want to go over to a lower ceiling area, to a more intimate space, and providing that variety of gathering and hangout, I think, is essential for any high school today. We also really, on this project, and this is, I'll say about 8 years ago that it was initially in design, we really leaned into tunable lighting. And this is basically a lighting system that the teacher is able to control the color temperature of the lighting from warmer to cooler. We installed it at all of our special ed classrooms, as well as the special ed preschool program in this building. So at the time, it was one of the largest installations. I hope to see it more and more as we go. It really provides a tool for the teacher to impact the behavior of the students. And, warmer temperatures when you're trying to calm things down, cooler temperatures when you're trying to get them to perk up and focus. So it's been a very interesting and helpful environmental experience for the students.
And I've talked about materials as they relate to their carbon footprint, energy utilization, but we also want to make sure that we're making our buildings healthy for our occupants. So when we're working on our specifications, we want to make sure that we're looking at all of the standards available to us right now to make sure that the materials selected are the top tier that are available. So that means that we're specifying non-toxic materials and that we're really prioritizing the touch surfaces. Well, we're trying to do this for all elements within the building. The data is not quite there for, down to every single nut and bolt, but especially when we're doing something like a pre-K space, we know those little kids are around touching everything and then going right to snack time. So we want to make sure that, they're in a space that's going to be healthy for them. All right, and then to shift gears a little bit, going back to the exterior of the building, Arlington High School's site is really central to the town, which means in their scenario meant that they're also a low point in town. So all of the rivers and tributaries of the area kind of were flowing downhill here, and we have Millbrook that you're seeing going through. So yes, it's a dashed line because it is buried underground, and then daylight's just down on the bottom right side of your page. It comes back to being an observable brook. This all meant that we really needed to be cognizant of stormwater runoff so that we weren't, that's how all those toxins get into our aquifers, is by running off the site, catching things along the way, and making their way into the water system. So we wanted to do what we could to ensure that wasn't happening from the Arlington High School site. And we did that in a few different ways. One of them on the upper left, you're seeing highlighted a rain garden. And so that rain garden space was designed to then capture all of the stormwater runoff that's coming from that roadway and parking lot. It flows in and it's captured into that rain garden, letting that water percolate and remain on site through there. Another way we did this is to have all of our more paved green spaces also incorporate landscape areas to them as well. So that's, again, offering spots for that rainwater to be captured, lessening the volume that's going on that paved surface that has to run off into areas outside of it. And then we also installed an underground infiltration system that is where the rooftop runoff was then piped and then makes its way into that underground tank, again, capturing it there, giving the rainwater time to percolate into the groundwater.
So in relationship to this, connections to nature, we started with a school building, as we've highlighted, which was in the lower left, you can see it in an aerial, was multi-generation and old. But one of the most obvious sort of fault lines was that it was paved all around it. And what I mean by that is a student had to cross some kind of pavement to get to nature. And we realized the detriment of that and the importance of the connections to nature and the ability to provide a variety of outdoor spaces for the student uses. So we have an amphitheater, which is connected to the performing arts space. We have a pollinator garden that Stephanie was just referring to. The entrances on both sides of the building. So at the front, we call the front lawn or the front green, is a large swath. And honestly, it used to be a green space, but no one went out there because they had to cross over blacktop to get to it. So the teachers didn't let anybody out. Now it's used throughout the day and absolutely hung out after hours for a nice day. And similarly, we created a plaza at the field side entrance, again, pick up and drop off and waiting for the bus. We have a central large learning courtyard between the STEAM and humanities wings, which is accessible from the central spine. It's accessible directly from the art classrooms that are able to go out and work on projects. And then there's a pre-K, as we mentioned, it has its own playground. The school is located, as Stephanie said, very centrally, and it had the Minuteman commuter bikeway, which is just to the north on this page to the right, and there was no connection. And so if you were on the bikeway, you had to take a very long, circuitous route to actually get to the high school or to the sports fields or anything like that. So part of our project was to make that connection and have a bikeway, all of which I think is can never be overstated, that these connections are so important for, again, health, wellness, sense of well-being. Yes, it's wonderful that we have all the glazing so people can look out, but that next step of being able to step out and engage nature is essential. And so just a little bit more about elements that we felt were very important to drive this project. We did note already the older building and all I think there was a quarter mile of corridors and lots of dead ends and very unwelcoming. But one of the things the students liked was the one thing they liked, with a level of autonomy. They could choose which way to go to get to their next class and that level of independence. So we kind of built that in. As much as our partie of this building is very straightforward, a student is able to stay to the less busy corridors or stairwells if they'd like, or if they want to go out and meet their friends, they use that central spine and that central form stair, create their own patterns and circulations. The images here are showing a variety of spaces that from little wooden nooks to the light wells with the counter, and then honestly, it wasn't part of the plan, but it turns out that the locker pod areas that we created are also a hangout. And the 18% is really wonderful to hear. So basically, they have done surveys of their students year over year. And with the first year of this being open, they saw an 18% increase of students' sense of belonging. And that really hits the mark for us. We were very happy to see that. And I think the last item we want to talk about is sort of using this building and the design and what's been done here as an inspiration for these students for their future, and to see what's possible, to learn about what's possible, what's been done, and why in the school. So we've done a number of things here. You see a large graphic that's right in the central spine. And then these round graphics are distributed throughout the building and really just give those little nuggets of information to, hopefully light a little flame of interest in the student about a particular topic that they can learn more about. And that does conclude what we had today. And I'm going to turn it back to Matt to help us with any Q&A.
Perfect. Thanks, Lori, and thanks, Stephanie. That was amazing. And now it is time for the Q&A portion of the event. There's still plenty of time to submit a question using the Ask a Question window to the left. And let's take a look at what we got. All right, our first question is, to To what extent did the client shape the sustainability vision for Arlington High School, and how did the design team influence those goals?
You want me to go first? I think we were very lucky in working with our Arlington client in that they kind of came to us with that town initiative and town master plan for where their sustainability goals for the town were already set in motion, and that's where we needed to go. So from the get-go, we worked with members of the building committee, formed a sustainability subcommittee. So it meant that we had a subset of members, other members from the town, members from the building committee, members from the design team working to further and all of the sustainability metrics. And it was a really kind of great think tank that, gave us the opportunity to really get deep into the weeds about the variety of topics that was outside of the bigger building committee, who had a large enough charge already to make their way through the whole design process of this 400,000 square foot school. So I think it was really invaluable for us to have a group that brought everyone to the table, that was able to dig deep into all the topics along the way, make decisions as a team, and then bring that back to the bigger building committee. And those decisions were, what are the mechanical systems we're going with? How are we going to integrate, triple pane glazing or not into the project? That was nice to have that group to fully vet all of our decisions with.
Okay. And then our next question is, what strategies did your team use to achieve ambitious sustainability goals within a public school budget?
And I know of one off the top of my
Sure.
head, but I know there's a whole bunch. I mean, I think that is a very good question. And I think that everything needs to sort of be vetted through multiple lenses and really considered. We sort of always are putting a lot of things on the table and getting costs for them, because that is very impactful, and working with the client to prioritize these things and make those can be tough decisions. Looking at this image in particular, this is that main teaching courtyard between the two wings. And I'm reminded that, there's always talk about triple glazing versus double glazing, and where would you put it and why? And there is a cost difference between that. And the ultimate decision to fit in the budget and to maximize, optimize where we put our money is a glazing like this long at the central spine here that you're seeing, as well as both the north and south main entrances of the buildings where we had multiple floors of glazing to the school. We used the triple glazing, but we did not use it everywhere else in the building. And again, this was being judicial with public funds and optimizing our use.
Yeah, I think that's, that generally our charge, where a lot of our projects are taxpayer funded projects. So, sticking to the budget that is decided upon is the number one priority. And then, it's our charge as the design team to start looking at the decisions. And, large construction projects, there's always trade-offs to be had, deciding how much tile height are we going to utilize? Is there money there that might be able to offset some other, sustainability metric that we need to bring into the building? So I think we strive to make sure that we're able to make all those checks and balances to make sure that we're making the right decisions for our client. I think the photos speak for themselves. This was still a, public project budget where we did have to make some trade-off decisions, but I don't think anyone would be charged to say that the aesthetics suffered for it.
No, the aesthetics in the pictures are amazing. And then our next question is, what were the most significant challenges in designing a fossil fuel-free public school?
Whenever you're looking at, 400,000 square feet of a building and saying, okay, I'm going to heat and cool that on electricity. I think tides are finally starting to turn that, in the U.S. construction market, that it's becoming more acceptable that, yes, you can do that on all electric systems. But again, where we were in just beginning design, 7, 8 years ago, that was a little bit of a hurdle to kind of bring people along the journey and say, no, we really can do this. There are systems that are capable of handling this load. So there became a lot of systems discussions and meetings that we needed to do to bring all those user groups along with the decision process. And then there's other kind of, I shouldn't say hidden, but other pieces of the building you don't think about. Hey, if your kitchen wasn't all electric beforehand, you would have to have that discussion with them that, now all of your cooking equipment is shifting to being electric ranges.
Which is a really big deal. And we were
Yeah.
really lucky because their kitchen
Yes.
was all electric already. So we've had clients since then saying, oh my God. I'm like, no, it's possible.
Yeah.
It's good to know, a good example that it is possible. And it also allows for, new clients who are considering, they have a good reference. They can reach out to folks on a project that have done it before. So it helps to perpetuate the positive steps that are being made towards creating healthier environments.